My name is Laurent Bernaille. I work for a small French consulting company called D2SI, and we do a lot of work on cloud and containers and helping companies deploy applications more efficiently. And lately we've been helping them a lot with going into production, and to do that we had to go deeper into how Docker works, because we need to understand when things don't work exactly as you would expect. You need to understand what's happening, and to do that you need to understand the inner working of Docker. And that's why I looked into overlay networks, and I'm going to present you what I found out, and we're going to discuss it like for the next 40 minutes. So here is the agenda for today. The first thing I'm going to talk about is I'm going to present the Docker overlay and give a quick introduction and build an overlay and see if it works. And then we're going to go under the hood and understand exactly how this overlay is designed. And the second part of the presentation is what we're going to do is we're going to build our own overlay from scratch, and we're going to make it dynamic afterwards, and I'll explain to you what this means. So let's get started. So first of all, here is the environment I'm going to use for the demo, because most of the talk is going to be demo based. So all the environment is running inside AWS. So don't focus too much into the detail. What's most important on this slide is we have 3 Docker engines at the bottom, so on 3 different machines, on 3 different subnets. And we have a console cluster that we use as a key value store. And you can see that the configuration of the Docker daemon is using the console as a cluster store configuration. So what this means is when we're going to create the overlay, the Docker engine are going to find each other using console. Okay? So this is how the old Swarm was working. In the new Swarm, what you can do is in Swarm mode, actually the key value store is part of Swarm itself, so it's in the engine, and you don't need an external key value store. And the reason why I'm using an external key value store there is it's going to help us see what's in there, and we're going to see how Docker is actually using console to store metadata. And in the end, we'll also use console to build our own overlay. So the first thing we're going to do is we're going to look at what's in console. So far there isn't much. So this is the console UI. It's basically connecting to console and showing us what's in there. And what I'm going to do is I'm going to click there on key values. And so when I started my Docker engines with the option I just showed before, it created this metadata tree inside console. So if you look there, we have all the nodes participating in the cluster. And if we go to network, in there you have all the networks created. So it's empty now because I just started my engine and there's nothing in there. So the first thing I'm going to do is I'm going to create an overlay network. So I'm just going to paste the command because we have many options. So I just created an overlay network. So I'm just going to go very quickly through the options. So this one is telling, well, I want to use the overlay driver. The internal option is basically saying, okay, I don't want my containers to have external access. I just want them to be able to talk over the overlay. And so it's going to make understanding how the overlay is designed much easier. And the subnet here is the subnets my container are going to use for the overlay. And you can just if you don't put anything, Docker is going to find an available subnet. And the reason I choose this one is because I wanted it to be very different from the subnet on the physical hosts, which are in 10.200 if I remember correctly. So I created my overlay, and what I'm going to do now is I'm going to check that everything is okay. So let's do Docker network ls. Okay, so I can see there my new network. Okay, and what's interesting is if I go to the second host. Okay, so the screen on the top is Docker 0, so one of the first hosts, and the one at the bottom is the second host. And as you can see here, I can also see on the second host the overlay network, so both hosts are connected. So what we can do now is we can check if we have actual connectivity between hosts being this overlay. So what I'm going to do is I'm going to start a container on the first host. So it's a very simple container. It's just a Debian machine running the sleep command. And what I'm going to do is I'm going to try to ping it from the other from a container on the second host. Okay? So this one is just a shell container, and what I'm going to do is I'm going to ping the first one. So what I did there is I actually put the IP address, when I created the container on the first host, I give it an IP address, I can easily ping it. And as you can see, it's pinging, okay? So I can also show you what happened in console just before going back to the slides. So as you can see in console now, you have this key, and this new key in console is kind of complicated, but we're going to look afterwards at what's in there. So let's go back to the slides. Okay, so this we did, it's pinging. Okay, here is what we built. So what we've built so far is I've created 2 containers on 2 different hosts, and I've created the overlay network, and I'm able to ping a container without any NAT, so natively on the overlay. So what we're going to do now is we're going to try to understand exactly what's in there. So the first thing we're going to do is we're going to go inside the containers, and we're going to look at the network configuration. So all the commands are in the slides, so you can get them afterwards, but I'm going to demo all this. So the first command I'm running, so this one is I'm executing inside the C0 container, and I'm looking at the IP addresses inside the container. So as you can see, I've got this IP address in 0.100. Okay, so this one, sorry. So it's the one I put in the configuration. And so it's the one I just pinged. Okay, what I'd like to know is I'd like to know what this interface is exactly. So what I'm going to do is I'm going to run another command that's going to give me this information. Okay, so instead of using IP address, I'm going to do IP link with details, and you're going to get much more information on the link. So what's interesting there is this interface is a VET. So basically a VET is a pipe with 2 endpoints, and what's interesting with these VETs is you can have one endpoint in one namespace and another one in another namespace. So here we have one end of the VET that's inside the container. So I'm just going to go back to the slides. Okay, so here is what we find out in terms of configuration. Well, inside the container we have NetNet VS. Okay, so the question now is, okay, where is the other end of the pipe? Okay, so if you're familiar with the way Docker works without overlays, usually the other end of the pipe is on the host namespace, and it's connected to the Docker bridge, and then it's netted to the outside world. So we're going to see if it's this way for overlay. So I'm just going to see if there's actually a VET inside on my host. Okay. So as you can see on my host, I've got my physical Ethernet address, a card, sorry, and the Docker 0 bridge, which is the default bridge, but no trace at all of the VS I'm looking for. So so if it's not in the host namespace, it must be in another namespace. So what I'm going to do now is I'm going to look at the network namespace on the machine and see if there's one that could be of interest for me. So this command here, for the people that are not really familiar with the IP command, is ipnetns allows you to run commands inside the network namespace, inside the network namespace you want. So here I'm just listing namespaces, and as you can see we have 2 of them. So one is the container we've created, and the other one is probably the thing we're looking at. Okay? And you can see that this one is kind of weird. You've got 1 dash and then figures. And what I'm going to show you is if we actually inspect the DockerCon network, so the one I just created, and get the ID for this network, you see it started with 7647, and it's exactly like the same as here. So this is this is the namespace where the VS is ending. Okay, so let's verify this. So this command here is executing. Okay, I just forgot to do something. I need to define the variable because I'm going to use it a few times. So overNS now is going to get to have the network namespace that's for the overlay network. Okay, so and now I'm going to execute this command. Okay, so let me copy it. Okay, so what I'm doing here is I'm executing inside the overNS namespace the following command, and I'm going to look at the detail at what's in there. So in there we have 3 interfaces. Okay, so we have like a loopback and 3 other interfaces. So what's interesting is we have a bridge, okay, BR0, and then we have a VXLAN interface, and we're going to look into that in detail afterwards. And as you can see, this VXLAN interface is hooked up to the bridge. Okay, so you can see it there. Okay, and you also have a VET there, and this VS is also hooked up to the bridge. Okay, so you have a bridge and 2 interfaces. And so we found the other end of the pipe we were looking for. So I'm just going to go back to the slides, and here is an updated version of what we found so far. Okay, so this is how the connectivity is working now. So the question now is, okay, you can imagine that this VXLAN interface is very important and is where the magic is actually happening. Okay, so what's VXLAN? It's basically a tunneling technology over UDP, and it allows you to send L2 traffic inside UDP in a tunnel. And at the origin, it was developed by Cloud SDN to create multi-tenancy. So one of the big issues of cloud providers was the ability to have different tenants sharing the same networks. And at the beginning, what they were doing is they were using VLAN IDs to segregate traffic, but it requires having L2 connectivity between all the hosts, which was kind of tricky. And you were limited to 4,000 VLAN IDs, so the 4,000 tenants or even 4,000 networks. Okay, so VXLAN was designed by networking gear companies like Cisco, Arista, and Broadcom at the beginning to solve this issue. In Linux, it started with OpenVSwitch because it was not supported by the kernel. It was used a lot for OpenStack, for instance. And it's been native within the kernel since kernel 3.7, and it even supports namespace now since kernel 3.16. And at the bottom of the slide, you've got schema of what the packets look like. So basically what you have is the outer IP packets that's going to be used for tunneling, where you have the physical IP addresses of the hosts. And inside you've got like the UDP header, the VXLAN header, and then you've got the original L2 frame that's actually what's sent by containers and received by containers. So let's verify that it's actually what's in there. So what I'm going to do is I'm going to back to the host and I'm going to see if when I TCP dump, I can see traffic on the VXLAN port. So I'm just TCP dumping on the Docker 0 machine, and what I'm going to do is I'm going to try to ping the container, so what I did before, from the other machine. So remember, on this terminal, on the second terminal, I'm on the second host and the second container. Okay. So as you can see, when I ping, I can see in the TCP dump the information on VXLAN, and for every packet I send, you get 2 lines. Okay, so the first line is the outer IP information, so the packet that's received by the host. And since TCP dump can decode VXLAN traffic, you have this second line in there, which show you the inner IP packet and the one that's used by containers. And you can even see that it's an ICMP packet. Okay. So here is what we have with the IP address in there that are showing you what's happening. So what's interesting now is when you are on the C0 or the C1 container and you need to ping the other one, the standard way to do this is first you need to find the MAC address of the remote IP, and then you need to find out where this MAC address is. So the first thing we're going to do is we're going to look at do we have like ARP information inside the network namespace. So let's do that. So the command I'm going to type now is just going to give me the neighbor list known on Docker 0 inside the overnet namespace. Okay? So in there, as you can see, this IP address here is the IP address of this container there. Okay? If I do this, you can see the IP address of the container on the Docker 1 host. And so inside the first host, I can see this ARP information, like the matching between IP address and MAC address. And what's also interesting that we can see is on the bridge inside there, we can even see that this MAC address there, so I'm going to highlight it. So what I just showed here is the bridge forwarding table inside the network namespace. Okay, so as you can see, the MAC address of the second container is known on this network namespace, and you can see that this MAC address is located on this physical host. Okay, so as you can see there, so this is the MAC address of this container here. Okay, ending in .2. And if I quit the container and look at this, you can see that this address here is matching this one. Okay, so it's basically telling like this MAC address is on the VXLAN interface, and to get to this MAC address, you need to send traffic to this physical host. Okay, the thing is, what I'm going to do now is I'm going to try a few more containers and see what's happening in there, and if I see immediately new information inside the first Docker machine. So what I'm going to do now is I'm going to run a container. So I'm running a container called C1 on the Docker 1 machine. Okay, and I'm going to create a C2 container also with another IP address. Okay, so I just created 2 containers on Docker 1. And if I go back here and I look at the neighbor table, okay, we can see that these two addresses and the matching MAC addresses are already in there. Okay, so by some magic, these IP and MAC addresses were just populated in there, even if there's no traffic so far. So let's go back to the slide. So we did this. In terms of how you're supposed to do resolution with VXLAN, you have several ways to do it. When VXLAN was designed, the first option was to use multicast to do resolution. So as you can see on the schema, basically what you do is you tunnel your actual traffic in UDP. Okay, so what we saw at the beginning. And when you need to send broadcast messages for information you don't have, like who has this IP address and where is this MAC address located, you just use a multicast group, and all the hosts in the VXLAN domain are listening to this, and if someone knows and has this MAC address, it's going to answer. So this is very nice, it's very elegant, but the main issue, and it's very efficient, but the main issue is multicast connectivity is not always a given, and in particular it's not available in cloud providers. There's no way you can have multicast inside AWS, for instance. So another option, which is even more simple, is to use point-to-point for resolution. So basically what you do is you say, okay, if you get an IP address or a MAC address you don't know, just send it to this host. Okay? So it's very efficient when you have two hosts, of course, so to have very simple tunnels. But if you have more than two, it's very tricky and very difficult to do. The final option is, well, you say VXLAN, don't do anything at all. I'm gonna manage myself the neighbor table and the forwarding database. So in that case, what's happening is you need, if you don't put anything in there, it's not gonna work. So you need to actually enter MAC addresses, IP addresses, and location. So where is a MAC address located? So you can do it by hand, but it's not very efficient. And the other way to do it is to have a daemon that's going basically to populate all this table. And this is exactly what the Docker daemon is doing. It's listening to event in console, it's getting the information, and it's putting the information inside the ARP table and forwarding database. So this is very flexible, but you need to have a daemon, and you need an external store for database of addresses. So what we can do now is we can see what's in console, for instance. So let's just go back there. So I remember I showed you what was in console before on the web page. It wasn't very nice because the keys are JSON encoded. It's like big JSON documents given by Docker, so it wouldn't show well, and it wouldn't show well in the screen. So what I'm going to do is I'm going to use curl to retrieve this and parse it. So the first thing I'm going to do is I'm going to get the ID of my network, okay, and then I'm going to curl to console and get the content of this, okay. So if we look at this URL, it's not that complicated. So you remember from the web page, these are the keys for Docker. So you've got networking information, and this is the ID of the network overlay we've created. And then we need to get the value because it's JSON encoded and it's base 64 encoded, and then you need, and then the content is also JSON. So that's why the command is kind of ugly. But in the end, we've got information on our network. It's basically the same kind of information you would get if you would do a Docker inspect on the network. And so you have several information, and for instance we can see here that we have the addresses that are going to be used on this network. You can also get from console, you can also get information regarding all the endpoints it knows, so basically all the containers that are part of the overlay that are attached there. So I could do it with curl, but it's kind of even more ugly to do it. So what I did is I wrote a small Python script, and everything that I'm going to use here is going to be available on GitHub, so you can have a look at it afterwards if you want. This one is very simple, it's like 4 lines, and it's going to go through all the endpoints inside the entire console, and it's going to display them. So as you can see here, we can see all the containers we have. So for instance, you have this C0 container with the IP address, MAC address, and the location is the physical host on which it's located. Okay, and so we have 3 containers on this now. Okay, so here is like the final overview of how the Docker overlay is working. So the only thing that's different from what I showed before is I added the ARP table and the forwarding database table, and the relationship with console, which is done by the Docker daemon. So the Docker daemon, when it creates a container, it puts information in console, and all the other daemons are going to get information and populate their own database. What we're going to do now is we're going to build our own. Okay, so far we've just like created a network overlay using the Docker overlay driver, and what we're going to do now is we're going to create our own with like standard Linux commands. So the first thing I'm going to do is I'm going to do a big cleanup. So I'm going to remove everything I've created so far. So the first thing I'm going to do is I'm going to remove all containers. Okay. And I'm also going to remove the network overlay I created before. Okay. Okay, as you can see, there's no more overlay. It should be the same there. Okay, so we're back to square one. We have these two hosts and nothing between them. Okay, so it's very simple. So what we're going to do now is we're going to build the main overlay components. And so to do this, we're going to use this set of commands. So it looks kind of big, but it's not that complicated. So the first set of commands is, the first command is I'm creating a network namespace. Okay, so netns add is creating a namespace, a network namespace. And then what I'm going to do is I'm going to create a bridge, and I'm going to put it inside this namespace, and I'm going to configure it with an IP address and a range. So that's the beginning of the first part. Then the second part here, okay, is the configuration of the VXLAN interface. So what I'm doing is I'm creating the VXLAN interface, and don't focus too much on options. We're going to get back to that afterwards. And once we've created this VXLAN interface, we're sending it to the namespace we've created, and we're attaching it to the bridge. And finally, we're bringing all the interfaces up. So if there's one thing that's important on this slide is the creation and the option for VXLAN, and we're going to go deeper into that afterwards. So let's just do it. So since it's kind of a lot of commands, I have a small shell script that I can show you. It's exactly what I just showed on the screen. Okay. The only difference you have at the top. Okay. If you have an overlay that's already existing, it's going to delete it, which is going to be handy afterwards. So let's just create this here and here. So on both hosts, I've created my namespace with the bridge and the VXLAN interface. And I can just check this very quickly. So ipnetns ls. So if I list my namespace, I can see that there's this one. And if I exec into this network namespace, IP links, for instance. Okay, I can see my bridge and my VXLAN interface. Okay, so here is where we are now. Okay, we just created this part. So very similar to what we had at the beginning, but we did it ourselves. So now what we need to do is we need to create containers and connect them to this overlay. So once again, this is looking kind of complicated, but it's not that much. So the first line should be very familiar to all of you. It's like I'm just creating a Docker container. What's important there is I'm using the net equals none option, which means once I've created this container, it's not going to have any network configuration. It's going to have only a loopback. The second two lines are I'm going to get the network namespace for this container so I can create interfaces into it. Okay, so it's basically getting this information during a Docker inspect. And then I'm going to create a V8, so you remember the pipe with two ends, and I'm going to attach one end of the pipe to my container, so the lines at the end. And in the middle, I'm going to attach the other end of the line of the pipe, sorry, to the bridge inside the overNS namespace I've just created. Okay, and at the bottom, you can also see that I'm going to configure this interface inside the container. So I'm going to give it an IP address and a MAC address. Okay, so let's just do that. So the first thing I'm going to do is I'm going to create containers on both hosts. Okay. And as you can see, if I exec into this container, demo IP link, okay. I've got only a loopback, okay. So there's no way this container is going to have any connectivity. And so now I'm going to run another script that's going to do exactly what I just showed you. Okay, so run all these commands. And the only difference is this time I've got parameters because it's easier. So the first parameter demo is the name of the container I want to attach. And then you've got a number, in that case it's 2, and it's the IP address, like the last digit of the IP address I want to use, and it's also going to be used for MAC addresses, as you can see like here. So it's kind of an ugly hack, but it's working fine for the demo, okay? So let's do this. And if I now if I go inside the container, I can see that I have this ETH0 interface. And if I do this, I can see that it's got an IP address ending in .2, okay, and same for the MAC address. And I need to do the same for the container on the second host, and this time I'm going to give it an address ending in .3, okay. So if I just do docker exec IP address, okay, this is basically the same, except this time it's ending in .3 instead of .2. So does it ping? Okay, so what I'm going to do now is I'm going to try and ping. Okay, so what this command is doing is I'm going to exec inside the container demo, and I'm going to try to ping. I could even run sh to do this, but it's faster this way. So it's not pinging yet. Okay, and the reason it's not pinging is we're gonna see this. Okay. I'm going to go to slides afterwards. Is there's no way my container on my first host knows about the MAC address and the location of this MAC address on the physical network. And if we look, and you remember the commands we had before to look at the neighbor table, so the ARP information known inside the overlay network, there's absolutely nothing in there. It doesn't know about anything. And if I look at the forwarding database for the switch or the bridge, there's several things, but there's no information regarding the MAC address I'm looking for and on which host it's located. Okay, so what we need to do is we need to give this information on both hosts, so they're going to know about each other. So I'm just going to quickly go back to the slides so I can show you the commands very quickly. Okay, so in the middle of the slide there, sorry, you've got these two commands and that are configuring the statically the neighbor entry and the forwarding database entry. So it's basically telling that IP.3 is MAC address 03, and that this MAC address is located on the host on the other side. Okay, so let's just do that. So I've got another script doing this. Once again, everything is going to be available on GitHub, so if you want to have a look at it afterwards. So basically this script is two parameters. One is the IP address I want to populate, okay, because I'm only using the last digit for the demo, and the physical host where it's located. So the 129.100 is this host there, okay, just as a reminder. Okay, it's this one. Okay, sorry. Oh, okay. I forgot to go back there. Okay, so this IP address here is this one, okay? And I can show you the script. It's very simple. It's exactly the command I just showed you. Okay, it's very simple. And now I can look again at what's happening in there. If I look at the neighbor entries, I can see that now I've got this information which I needed. And same for the bridge. Okay. I can see that I have this line there, which is exactly what I need to know to find the container. So, does it ping now? Okay, let's try this again. Okay, so it's still not pinging. And the reason for this is pretty logical, is I've given the host, on the first host, I've given all information regarding the second one, but not for the other way around. So basically traffic is getting to Docker 1, but the thing is, it cannot get back. Okay, so what I need to do now is, I need to go into Docker 1 and do the same thing. So just before doing that, I'm going to show you something that's interesting is, so as expected, there's absolutely nothing inside the neighbor database because we didn't put anything in there. But if I look at the bridge forwarding table inside the overlay namespace, okay, I can see this. And this was actually dynamically learned when my ACMP request arrived. The network namespace learned where this MAC address was located in terms of VXLAN, so it knows the way back in terms of MAC address, but it's not working yet because I don't have the ARP information. So I'm just going to add this in there, okay? So I'm just giving information on what's matching between IP address and MAC address. So now I got this new information that was missing before. And now this time, if I ping, it should work. Okay, great. it's nice to be uploaded for pinging, you know. So let's just go back to the slides. So I don't know what happened there. Okay. Okay, so now it's pinging. Okay, so here's what we built. Okay, so it's very similar to what I showed before. It's just that we did it ourselves without any intervention from the Docker overlay driver. So what we did so far was very manual. I mean, I had to add the entries, MAC addresses and locations manually, and that's not very nice. So what I want to do now is I want to make it dynamic. I want to create container on both hosts, and I want them to be able to find each other. So the first thing we're going to do is we're going to do a lot of cleanup. So I'm going to just remove all the things I've created. So I'm going to just remove IPNetNS delete, I think, over NS. Okay. So I cleaned it. So I removed the overlay namespace I created before, and I'm going to recreate it. Okay, on both hosts. Okay, so I did something that I shouldn't have done, which is like always happen when you do demos. Okay, so I'm doing exactly what I did, exactly the commands I went through before. So I'm creating the overlay and attaching containers, and I need to do the same for this one. Okay, and the thing is, I'm going to make it dynamic, but I'm going to work only with one host, so I need to repopulate to put all the information back into this one. So I need this and okay. I hope it's this. Yeah, okay. No. I need to, okay, it should be okay. I'm just going to verify that everything is okay inside the container. So, okay. IP. Okay, that's look about right. So I've got IP.3 inside the container, and I'm just going to check that this is working fine. So I've got information regarding the other host, so IP.2, and is the bridge, and I need also to look at the bridge information, and I'm good. Okay. No, something is missing there. I should have, okay. So I need, okay, so I need this, I think. Okay, okay, it looks a lot better. Okay, so just very quickly, sorry about that. What I did is I wanted to delete the overlay names network inside only one host and to rely on what I've done before on the second host. And what I did, because I did it too fast, is I deleted it on both hosts, and so it would not have worked afterwards. Okay, so on this host, we have the overlay created and a container attached to it with no IP information or anything. With IP information, but no neighbor table, okay? And if I look at the, okay, so everything is empty, and this is this part that I want to make dynamic afterwards. Okay, so let's go back to the slides. So what I'm going to do is I'm going to try to catch network events. So we're going to use Netlink. So Netlink is a kernel interface for communication between the kernel and the user space, and it's designed to exchange networking information between the kernel and the user space. And it's basically what we all use when we do IP route. When we use IP commands, it's using Netlink to communicate with the kernel. And you can get information from the kernel and send information to the kernel. So you can use Netlink for several things. The most common protocol is Netlink route, which is managing all the link and route information, and it's the one we're going to use. But you have several other ones. And inside the Netlink route, you have different kind of notifications, so you can get information regarding links, routes, neighbors. So a link notifications could be a link going up or down, these kind of things. And the type of notification we're interested in is information regarding neighbors. Okay, neighbor is ARP information, like do you know who this IP address is, or where is this MAC address located? And you have different kind of events. For the neighbor notification, you have new neighbor, deleted neighbor, and get neighbor, which is the one we're actually really interested in, because when we're going to try to ping from our first container, the second one, we're going to generate an ARP query, like who has this MAC address, and this is the one we're going to get. So I'm not going to go into too much detail into this, but this is just to give you an idea that a netlink packet is actually pretty simple, and the code you need to decode it is actually like maybe 15 lines, okay? So the orange part is like the standard netlink message, a header, and then you've got the blue part is the network discovery messages, so the one we're interested in for get neighbor, and then you've got the information of what you're actually trying to get from information. And for instance, in that case, we have an IP address and we want to get a MAC address. Okay. Once again, this code is on GitHub. A very small thing there. At the beginning of the code, what I do is I bound the netlink sockets, and and then I'm filtering for neighbor events. Okay, and then I'm just decoding this. The binary format of the message. Okay, so let's go and do this. So what I'm going to do now is I'm going to disconnect from Docker 1 and connect to Docker 0, and I'm going to try and catch these events. So I'm just going to copy paste the command so I try to avoid issues. Okay, so basically I'm execute the script I just showed you inside the network namespace I created. Okay, so here it is. And now what I'm going to do is I'm going to try pinging. Okay, so as you can see, the script just codes these ARP queries. Okay, so it's an L3 miss, which is like I've got an IP address and I'd like to know what the MAC address is. So let's give it the information. So I'm just going to give it the information. So same script as before. Okay. So this script, the populate IRP script, is just giving information regarding MAC address and matching between IP address and MAC address. So I'm just going to do this. Okay, and I'm going to try and ping again. Okay, so as you can see, the difference now is instead of having a question regarding who has this IP address, the question is, okay, where is this MAC address located? Okay, which is information I need to be able to route traffic. So I just need to add a last piece of information, which is the bridge information, and now it should ping. Okay. Okay, so it's pinging again. I just say who because since I did a lot of bad things on the other host, I was afraid I didn't fix it. And so as you can see now that it's pinging, you're not getting any more misses there because the information is already inside the database. So let's just go back to the slides. Okay, so now I showed you how we can get this message, but it's still very manual. I had to enter to put the MAC information and forwarding database information inside the machine. So what I'm going to do now is I'm going to make it dynamic. So I'm going to write a script. I'm going to use a script that's listening to this event and getting information from console to populate the databases. So let's just run this script. Okay, so instead of running this one, I'm going to run the other one. Oh, sorry. Okay. I need to switch there. Okay, so I'm just going to remove everything I had before. So I'm just recreating the overlay. Sorry. I need to go faster. Okay. So I went back to square one. I've got my containers. It has got an IP address, but it has no idea where the IP address, where the MAC address is for the IP and where the MAC is located. And the thing I'm going to do is I'm going to put all this information inside console. So you can see that all these commands is basically a very simple curl command. I'm going to put information inside console. Okay, so let's very quickly look inside console. Okay, I created this demo tree, and inside I've got ARP information, and this IP address is matching this MAC address, and same for this one. And then I've got the same information for the forwarding. So, sorry, this one, it's hard to click. Okay, so this MAC address is located on this host. So it's everything I need. Okay, and the last thing I need to do now is I need to start the script that is listening to event and looking for information inside console. So let's just go back to this, okay. So this script is listening to the events I just showed you before, and now I'm going to try to ping. Okay, this should work. Okay. Okay, so let's look very quickly at what happened. So the script first called the else remis, okay, this question, and it got information from console, and then it put it in the ARP database. And then, when this was okay, it got this L2 miss, which is basically where is this MAC address located, and SEM got the information from console and put it in the forwarding database. And afterwards, everything was pinging. So I'm slightly behind in time, so I'm just gonna conclude now. So here is a summary of what we built, with the relationship between netlink, my Python script, and console. I've got a very quick summary on VXLAN options, which I can show you afterwards. Basically, all the options that are there are the ones you need to make it work. So the one that's most important regarding what we did today is L2 miss and L3 miss, which are generating the getNay events. Okay, without this option, it wouldn't work. I've got a few things that are just, if you want to replicate this, there are a few tricks, okay? So I didn't plan to show it to you, but when you have access to the slide, you can look at this, and we can discuss it if you have questions afterwards. And I'm done. So all the code I showed you is on my GitHub, so you can have a look at it. And if you have questions, don't hesitate to ping me on Twitter. I'd be really happy to discuss it with you.